The following video contains some accident scene imagery which may upset some viewers. Viewer discretion is advised. Animations used in this video have been developed using evidence gathered during the investigation and are displayed for illustrative purposes only. They are not to be used for further analysis. The Australian Transport Safety Bureau's final report into the mid-air collision involving two Eurocopter EC-130B4 helicopters operating scenic flights on the Gold Coast in Queensland contains 28 safety factors that provide valuable lessons to flight crews, operators and other organisations conducting high-frequency scenic operations to improve safety. Shortly before 2 p.m. on the 2nd of January 2023, Helicopter X-Ray Hotel 9 departed from SeaWorld Helicopters Helipad number 3 on a 5-minute scenic flight with a pilot and 5 passengers on board. Concurrently, at a separate helipad within the SeaWorld theme park, Helicopter X-Ray Kilo Quebec was being loaded with passengers in preparation for a 5-minute scenic flight. Returning via the Broadwater, X-Ray Hotel 9 turned onto a final approach path for a landing back at Helipad 3. At this time, X-Ray Kilo Quebec, with a pilot and 6 passengers on board, became airborne, climbing over water in the direction of a sandbar. About 24 seconds into its flight, and at a height of about 130 feet, the two helicopters collided. The simultaneous use of these two nearby helipads created a conflict point where the helicopters collided. The collision occurred when the helicopters crossed paths at an angle of 73 degrees, with a relative horizontal velocity of 77 kilometres an hour, with X-Ray Hotel 9 descending and X-Ray Kilo Quebec climbing, which created a vertical closing velocity of 1,220 feet per minute. The main rotor blades of X-Ray Kilo Quebec pierced the lower forward cabin windows and windscreen frame structures and passed through X-Ray Hotel 9's forward cabin multiple times. Both helicopters' main rotor discs passed through each other, with the main rotor blade of X-Ray Hotel 9 exhibiting damage consistent with contact with the main rotor blade of X-Ray Kilo Quebec's. The nose of X-Ray Hotel 9 then collided with the fenestron of X-Ray Kilo Quebec. 2 seconds later, X-Ray Kilo Quebec broke up, with the fuselage, main rotor and fenestron falling separately onto the sandbar below. The pilot of X-Ray Kilo Quebec had no opportunity to conduct a safe landing, and 4 of the 7 people on board the helicopter were fatally injured. 3 were seriously injured. Video recordings of the collision showed control of X-Ray Hotel 9 was momentarily lost. However, the pilot quickly regained control after the initial contact and conducted a controlled landing on the sandbar below, which was a pre-selected forced landing spot. 3 of the 6 people on board this helicopter were seriously injured. The 3 others received minor injuries. The investigation found that an inbound radio call made by the pilot of X-Ray Hotel 9 failed to register with the pilot of X-Ray Kilo Quebec, who was on the ground at the theme park's helipad loading passengers at this time. During the latter stages of its flight, the pilot of X-Ray Hotel 9 elected to wait for a taxiing call from the pilot of X-Ray Kilo Quebec to signify their departure as a cue to arrange separation between the 2 helicopters.
It's likely that the pilot of XKQ missed the inbound call made by the pilot of XH9 at Porpoise Point due to passenger loading and cabin preparation activities. And beyond that point, no further relevant airspace information was available to that pilot. That's due in part to the operator's documented procedures allowing a reactive approach to separation. In line with the minimum regulatory requirements, the pilot of XH9 was only required to make another call if they found it reasonably necessary to avoid a risk of collision. Now, the pilot of XH9 saw XKQ on the helipad, discarded that helicopter as a threat, and expected a taxi call should that condition change. So it's almost certain that a taxi call wasn't broadcast, and the evidence available showed that the pilot of XKQ likely made a call, but that was subject to transmission failure. The image shows the readability rating of calls from XKQ over 2 days leading up to the accident. It was recorded at a nearby airfield, and as you can see, most of the calls were of very low quality or entirely absent. Contrasted with the calls made from XH9, which was the same helicopter type, using the same equipment, flying the same routes, and at times with the same pilot, we can see that there's an obvious issue with the radio in XKQ.
Components of the radio systems of both helicopters were recovered for examination and testing. This included the pilot's headsets, radio components, and the antenna and pilot's radio transmit switch from X-Ray Kilo Quebec. Following inspection, while most components were found to be functional, a fault was identified in the radio and antenna that the pilot of X-Ray Kilo Quebec was using to broadcast on the CTAF. Both pilots were unaware of the existence of defects in the VHF radio on board X-Ray Kilo Quebec that limited transmission range and likely prevented the broadcast of the pilot's taxiing call. During their wreckage examination, ATSB investigators identified faults within antenna components connected to X-Ray Kilo Quebec's communications radio. While connected to a handheld VHF radio, the antenna received broadcasts on 2 different frequencies without issue. However, transmission tests failed. Micro-CT scans of the antenna and the BNC connector identified a crack indication within the solder joint between the circuit board and the link wire to the antenna base, which can impact both the transmit and receive functions of the antenna. It was noted that the fracture surfaces of the solder region were discoloured from oxidisation, indicating that the cracking and fracture had not recently occurred. Additionally, a potential defect was indicated where a single wire was identified to be protruding from the centre pin within the BNC connector. A single strand of wire from the core of the coaxial cable was found uncontained and outside of the contact pin. Communications experts indicated that an electrical fault could develop in the BNC connector if that wire contacted the main body of the BNC connector. The interaction between the stray wire and the BNC housing can cause unwanted coupling, which distorts the RF signal. This distortion can lead to issues such as reduced range, poor signal quality, or even total failure to transmit or receive. To assist in the investigation, the ATSB initiated a cockpit visibility study to examine when each helicopter would likely have been visible to the other pilot. A simulation was developed in collaboration with Airbus and a simulation expert that showed the location and orientation of each helicopter leading up to the collision, and validated by using video collected of the accident sequence.
The cockpit visibility study determined that from the pilot's eye position of each helicopter, a direct line of sight to the other aircraft wasn't always possible. What we can see here is the view from the pilot's eye position of X-Ray Hotel Niner looking directly ahead and in real time. What we'll see as we track down the broadwater is X-Ray Kilo Quebec sitting on the park pad. As X-Ray Kilo Quebec lifts from the pad, it will then transition to be shielded behind the left cockpit pillar of X-Ray Hotel Niner. X-Ray Hotel Niner will then make its approach to Heliport Pad 3, and we can see the vessel that the pilot of XH9 identified they needed to pass behind. As we continue along, we can see X-Ray Kilo Quebec is unshielded to the left or outside of the cockpit pillar and then transitions across it in the lead up to the collision. So what we have here is the view from the pilot's eye position of X-Ray Kilo Quebec looking slightly to the right. We can see the cockpit structure, the same as was presented for X-Ray Hotel Niner, but in this case what's been done is it's been made semi-transparent. This allowed investigators to see objects that may have been otherwise shielded by the structure in the lead up to the collision. We also know that the pilot of X-Ray Kilo Quebec was wearing a cap for the flight, and to assess what impact that may have had, investigators modelled the peak of that cap, and you can see that presented in the simulation as the blue area at the top of the screen here. So what we can see here is X-Ray Kilo Quebec lifting from the park pad and then rotating to the right to start its transition towards the sandbar. We can see here the vessel that X-Ray Hotel Niner had identified that they needed to pass behind. If we look here at the top of the screen, we can see X-Ray Hotel Niner is shielded by the cockpit structure. It then continues to be so right up until the time of the collision.
Visual acquisition is one of the primary tools at a pilot's disposal to assist them in the location and identification of traffic around them. However, as shown by this study and a volume of previous work, it is unreliable on its own. Supporting see and avoid with other means allows direct searches, which are 80% more successful than unaided acquisition.
Scanning outside and moving to avoid aircraft structure is a vital tool for pilots to maintain and manage separation with other aircraft. However, it's well known that see and avoid has significant limitations. Searches will not always be successful and traffic will not always be visible. This report carries details on 25 other investigations which quite regrettably carry very similar findings. See and avoid on its own is not a robust defence. Communication between pilots is vital. Alerts to target searches, conspicuity devices to attract attention, and intersections that are designed to support pilots in being able to identify conflicting traffic. Operators need to look at all of these investigation reports and consider the findings of them within the context of their own operations.
Both pilots were required to manage separation from vessels on the water to prevent their helicopter's downwash from affecting their operation. Prior to the collision, a vessel was operating underneath the arrival and departure paths of both helicopters.
So the pilot of XKQ intended to pass to the west of a vessel on the water, while the pilot of XH9 intended to pass to the north of the same vessel. The pilot of XKQ also had to check another conflict point to the south, SeaWorld Grass, and the pilot of XH9 had allocated their attention to their approach and landing. The limitations in visibility, combined with those competing priorities and the incorrect understanding of where the other helicopter was, led to a mid-air collision at that conflict point that had been created by simultaneous use of those two nearby helipads.
SeaWorld Helicopter's passenger safety briefing system, comprising of a video supplemented by safety cards and ground crew advice, had limited, inconsistent and incorrect information about the correct fitment of seatbelts, the location and emergency operation of EC-130 doors, and the emergency brace position. The investigation found that passengers on board both helicopters were incorrectly restrained by their seatbelts. To be an effective restraint in turbulence or an accident, seatbelts, no matter what kind, must be fitted correctly. For multi-point seatbelts that don't already have the shoulder harness attached, it is important that the lap portion of the belt be fitted first and adjusted low and tight across the hips before the shoulder harnesses are connected to the buckle. An incorrectly tightened or loose lap belt can result in the shoulder harness pulling the lap belt up off the hips. Seatbelts must not be fitted across the abdomen, as this can cause internal injuries or result in the person sliding out of the bottom of the harness, known as submarining. Seatbelt straps must not be twisted and must be fitted without slack, as tightly as comfort allows. No matter what aircraft type you're flying in, whether as a pilot or a passenger, your seatbelt must be worn correctly to help improve the likelihood of survival in an accident. When a person is not correctly restrained, this can affect the performance of the seatbelt and also prevent other safety features, such as crash-worthy seats, from working as designed. Life jackets are an important piece of equipment when flying over water. Pouch and yoke-style life jackets ensure the wearer has immediate access to the life jacket should it be required.
While we were unable to correlate the level of contribution of incorrect restraint to passenger injuries, it is well known and there is significant research that shows that wearing your seatbelt correctly can improve outcomes in the event of an aircraft accident. It was a regulatory requirement for passengers to be wearing life jackets in this type of operation, and of course they had to be wearing their multi-point seatbelt. The ATSB is unaware of any research or testing that shows the best method of integrating these two pieces of equipment while maintaining the integrity of both. What we found was that helicopter tourism operators worldwide were incorrectly fitting seatbelts in conjunction with constant wear life jackets. Research and testing is required for the combined use of constant wear life jackets and multi-point seatbelts to ensure guidance can be developed and provided to operators to ensure that passengers are correctly restrained. Addressing this gap in research will provide a positive impact on passenger safety worldwide.
The ATSB's systemic investigation into this tragic accident was one of the most challenging and comprehensive to date. Over 400 pages across 2 reports have been published on the ATSB's website to support the 12 safety issues given to the operator and to the regulator.
This accident wasn't one day in the making. The operator had made a number of changes to improve their business and had elevated elements of the operation. However, the changes came with unintended consequences and over time undermined the risk controls that were previously used for management of separation of company helicopters. The changes also reintroduced the conflict point at which the helicopters collided. Now, these unintended consequences weren't captured because the operator's SMS didn't effectively engage with aviation safety risk. One of the most fundamental lessons is that changes that are intended to improve aviation safety can have unintended consequences. And without application of change and risk management processes, it can't be reasonably determined that those changes won't undermine existing risk controls. So consequently, there's a need for SMS with defined objectives that match the operator's business and a deliberate and effective engagement with aviation safety risk.
You can read the final report on the ATSB's website by searching AO-2023-001. You can also read the cockpit and visibility study by searching AS-2023-001. A link to both reports is available in the description below or from a link in our bio.